Hello, ladies and gentlemen. I want to show you how to use double number lines to solve equations. I really like this method because it reinforces the number sense involved in using number lines, and it explains or reinforces the steps that we take in algebra to solve equations by connecting them to the ideas of transformations. So let's before we get started, I want to remind you that if you want to pause the video at any time to try to work out a problem before it's finished, and then compare the way you did it with this method, and just see if we did it the same way, see which one you like better, see if it helps uncover anything for you. So let's get started. On this first problem, what we want to do is anchor our number lines whenever we get started. So I'm just picking a spot. I'm going to say that's 0. So the cool thing about these number lines is that anything vertically aligned is equal, and that's what we got to keep as we move forward. So we're going to call this 0x. So 0 and 0x, vertically aligned, those are equal. Out here, I'm just going to draw a line where we think it fits. We're going to say that's 12. That's our left-hand side of the equation. That's 12. And then the right-hand side, since they're set equal, we got to put it right underneath and say that is 3x's. And then I'm looking at this, I'm thinking, well, we're just kind of counting here. Here's 0 x's, and that would be 1, and that would be 2 x's. So that would be 1x, and that would be 2x. So it's just a natural way to count that off. 0, 1, 2, 3 x's. And then if we look at the top, we gotta do the same thing. We gotta break this up. And it looks like we broke up that space of 12 into 3 spots, 3 equal parts, and we would say that must be 4 and that must be 8 because that counts regularly. 0, 4, 8, 12. If we went one more, that would be 16. And to keep it equal, we would say that's 4x's. So far all we've really done is played around, got a sense of the space of this number line. But we've also solved the equation. We found out that 1x is 4, and that equation is now solved. It's pretty cool. All right, let's look at another one. So again, the first step is anchor your number line. So my 0 and my 0x. I would say right about there is my 1/2 x plus 5. And directly above that, looking at the left-hand side of the equation, that is 15. Okay, well, I don't really like half x. So I'm thinking about this space, that step. And what I'm going to do is I'm going to double it. I'm going to take that size step again. So what that means is you add it to itself. So a half x and a half x is a whole x. To get out here, it's a whole x way. And plus 5 and plus 5 is plus 10. I doubled everything. 1/2 x times 2 is x. 5 times 2 is 10. So you can see that doubling and adding to itself is really kind of the same thing, whichever way you prefer to think about it. And what we need to do is mirror that. Whatever we did to one line, we should do to the other. And so this space is 15, so I need to take another step that big, and we find out that that's 30. Okay, so now I'm focused in on that x plus 10, and I want to get rid of that 10. So I'm going to backtrack minus 10 and end up right there. I already know we're going to have to do that on the other side too. So x plus 10 minus 10, that would just be x. That's where x lives. And 30 minus 10 is 20. And there we found it, that our x value is 20. All right, I want to do that one for you in another way to show you that it's really okay to be creative and do what makes sense to you. There's not one way to do this. There's not a preferred way to do this. So I want to show you that on this problem. So we start the same way. We'll say, hey, that's 15 right there. And this is 1/2 x plus 5. All right, so last time we tackled the 1/2 first. This time I'm going to take care of that 5 first. So I don't want the plus 5, so I'm going to come back here and say minus 5. And I'm going to do that to both sides. So if I take 5 off of this expression here, I'm just left with 1/2 x, because 1/2 x plus 5 minus 5, you just have 1/2 x. So then what we got to do is take 5 from the 15 so that we can keep the vertical pieces equal. So 15 minus 5, we would be right here at 10. And then I'm thinking, okay, well, if half x gets me there, then full x must be right there. That must be where x lives, right? So if we take that same size step again, we double the half x, we should end up at x. And that same logic on the top, if that far gets me 10, then that far gets me 20, and I've finished the problem. X is 20, and I've shown it another way. Let's do one more. Hopefully the first step is down. We got to anchor these number lines. Ooh, this time we're dealing with b's. So 0 is the same thing as 0b. So out about, I don't know, here, we're going to say this is 4b plus 1. And 4b plus 1 is the same thing as 20. Let's break down what this means. We have 4 b plus 1s. That means it took us 4 of that size step to get out here. So right here halfway, this must be 2 b plus 1s, because 2 is half of 4. And so if we break those up, then this must be b plus 1, and this one must be 3 b plus 1. Excuse me, my b is a little bit messy there. Let me fix that. I don't know if that's any better or not. But you get the idea. We're counting by b plus 1s. So the first one is there, the second one, we have the first one there, the second one, the third one, the fourth b plus 1. So we've divided this into 4 equal parts, so we should do that on the top as well. And cutting this range in half, 20, half of that is 10, and cut that in half again, you have 5, and that means this would be 15. So we've learned a lot. We still don't know what b is yet, but we're getting closer. If we look at this space right here, we see that b plus 1 is the same thing as 5. So if we subtract 1, we end up right there in the number line, and that space would be b, and 5 minus 1 is 4. So we found out that b is 4. Well, I hope you like this different way of looking at solving, and hopefully it helps make sense of the balance that we're trying to do when we solve equations and why we do the steps we do.